C.
It is C, yeah. 13 minus 2 times 8, does that equal -3? Yes, it does. Okay, all right. So the reason you might use the table method is maybe you're much better at substituting numbers in compared to actually solving the system, all right?
Hmm.
Okay, now
Yeah.
let's do another example here. So again, this generally applies to systems. You will get a system on there, and you might think, I already know how to solve a system. You probably do, but this is about saving time. If you use this method, it'll save you time, and then you will gain time for other problems. So this one, they're giving you y, which means you need x in your table. Okay. So if we use the first equation, y is x plus 2. Now, what you could do is you could quickly solve this for x. You could say, all right, x is really y minus 2, which means each of these y values you're going to subtract 2 from. Or maybe you're just like, oh, I know how to figure this out. I'm at 0, 1, 2, 3. That gives me my x values. Okay. That's up to you. Now, because we like things in order, at least I do, um, I'm gonna I'm gonna rewrite these y values here, and I'm gonna cross them out here so that I'm looking at it as x and y, because it's very easy to flip the variables, especially when you're under a stressful situation. It doesn't take that long to rewrite it. Now we just try it in the second equation. So let me know which one of those work, please.
A.
It is letter A. Good. Okay. So in truth, full disclosure, that is the table method. I mean, that's it. Like you basically just build a table for the two variables. It does mostly apply to systems. It will apply to some word problems. It's not glamorous. It's just another technique, another tool in your toolbox here. Um, so you have to make sure you know when you're looking at the question, like which one are they giving you? Oh, they're giving you X, which means you need to find Y. So which equation should you use to find Y? Well, this one isn't as good, right? It's like, man, I don't see a good way to get to Y here. So you might argue with me, well, maybe this isn't the right approach. I will still argue that this is a good approach, and I'll show you why. I'm going to solve this one for Y. All right. So this is as you end up getting how do we want to do this? So let's go x minus 16 equals 10y. So basically swapping positions with those. And then y equals x minus 16 over 10. All right. All right. So first thing is we're going to put this x value in here. 9 is 14 minus 16 is minus 30 over 10 is minus 3. Minus 12 minus 16 over 10 is minus 28 over 10, which is minus 2.8. That's not good. And then minus 4 minus 16 is minus 20 over 10. That's minus 2. 60 minus 16 over 10 is 0. So this maybe looks bad, but um, we know it's probably not B. We hope it's not
Hmm.
B. And the whole point of like looking at the solutions is you should learn something every time you do it, or look at the solution, be like, well, I'm probably not going to try that one. Okay. So maybe you try, one of these other ones. Like, I don't know, but you're going to try them in the other equation. And maybe you try like the one with 0 in it first, or you try the smaller numbers first, or you say, oh, that's really big, or I don't know. You maybe make some decision. What do you think here?
Well, C.
Let's see. All right. Any questions on this approach or this method?
I don't think so.
Okay. Now you can see and like you do not have to use these methods. Like you can say, you know what, Matthew, I'm going to solve with systems. And I'm like, yeah, that's fine. Like that is totally fine. This is just it's just me showing you like this is another way to do these problems. And like it doesn't it doesn't matter if you use it or not. You know, it's just
Hmm.
another strategy. Okay. It works on like one problem or maybe two, but you know, uh yeah. So here's a word problem though. Okay. Um, again, we read the last sentence first. How many hours did Angela work? So that's Angela's hours there. Now we're going to find out about Raul. We know that the total is 59. So that means that this is 35, 24, 19, and 11. I'll let you
Hmm.
read the question and maybe you can tell me the answer with this table.
It would be A.
Good. All right. So let's have you try a few problems here. You do not have to use this method. You can use the table method. You cannot, in any event, you're going to get some practice with systems. So I will leave it up to you how you want to approach how you want to approach these, but give this a try, please.
Is it C?
Okay. So this is the value of y. Did you use the table method or did you use another method?
I use the table method because two of the options would be removed if we did that.
Okay. Did you use the first equation or the second equation to solve for x?
Um, I use the first equation.
Okay, so x is equal to 6 times y. So you multiply the y value by 6, so 12, 24, 72, and then 144. And then my suggestion is to rewrite the y's. And one of these should work. Now you said you think it's the C. Did I hear that right?
Yeah.
It is not C. Give that another look, please.
A.
It is A. Good. All right. So like one reason you might consider using the table method is that they sometimes use non-standard numbers and you know solving it could just be kind of awkward. But um, yeah, I would recommend using the table method. You were right here, like probably for sure D is out. Like that's I mean it's really extreme for a system. Um, yeah, sometimes you can just use reasonableness for that. But here, take a look at this one. Use whatever method you want to solve for X.
Let's see.
It is. It is good. Which equation did you use to find y if you
I
use the table
used
method?
I used the first one.
Okay. So to me, that means you did like 16 minus x divided by 2.
Hmm.
Okay. Now, one of the reasons that works is because all of these are even numbers. That you could actually use either equation. So hopefully your table looked somewhat like this, and then you would solve. All right. MSC. Good. All right. Now the table method actually works for more than just linear systems. This is a nonlinear system. It's nonlinear because the first one's a quadratic, second one's a line. Um, so blah blah blah. This is asking for the y values. So if you wanted to find the x value, probably want to use the second
That one,
equation.
yeah.
And it's like it, you could sit here and try to solve this by substituting, x minus one in here and moving it over and factoring. That all work. And maybe you're really good at that, but maybe you're just like, yeah, I like this table method. It works really well for these other problems here. So I'll leave you to that. Take a look here, make your table if you want, or solve. But yeah, this one, give this one a try, please.
Is it two?
Which one, A, B, C, or D? Oh, you're
C.
saying C? Yes, yes, it is. Good. Really, really good. Did you use the table method or did you substitute in?
I use the table method and then,
Okay,
yeah.
good. Appreciate you trying that out here. Let me show you how you would solve this if you didn't know anything that I was talking about. You would write y equals x minus one. That goes in here. And then it becomes x squared minus 6x plus 11 equals x minus one. You'd move things over, minus 7x plus 10 equals 0. You'd get x minus 5, x minus 2. So x is either 5 or 2. That's not what they're looking for. They want the y coordinates. You'd still have to go back and solve for y, and you're subtracting those two values from 1. Uh, or I'm sorry, you're adding 1 to them. Uh, what am I doing here? Sorry, what is are these right? 5 and 2. X is 5, y is 4, or y is 1. I might want to change my answer here. I think you got X is 2.
Why would it be four or D?
Yeah, it's a good question. As my notes say, it's the other one. And when I try and look at my notes, figure out what's going on. 3 squared. Yeah, so that is right. What did I miss here? X squared minus 6x plus 11 equals x minus 1. No, because I got the wrong number here. That's why. This is 12. So that's a great example of how if you direct solve it and you direct solve it wrong, like I just did, which does happen, and you get 3 and 4 now, um, you know, you have to still keep going. You have to say, okay, 3 minus 1 is 2, 4 minus 1 is 3. Like there's no guarantee that direct solving it is the way to go. But it's always an option. So don't feel like, hey, uh, the this is the only option. So um, let me put one more in front of you here before we switch to we'll do a content area here. I would recommend using the table approach for this, but it's up to you. I'm going to step away for 30 seconds, but I'll be right back with you. All right, how are you doing on this one?
I'm still solving.
Okay.
Is it D?
Yes, it is D. Very good. All right. One more of these that's a word problem. Um, and then we will truly move on to a new topic. This is another table problem. So the they're giving you Sadie's purchases. You can think of it as Sadie or novels if you want. It's up to you how you do that. But um, go ahead and take a look, see what you come up with.
Number they gave us is the amount of magazines, right?
Uh, this is how many novels. So that's
Oh,
why. So it's like I guess I would call it N. She buys both novels and magazines. I was trying to say like the Sadie's novel or something, but it probably better just to use N for that.
um, is it B?
How much? Yeah, how much does a novel cost?
4.
I'm sorry, how many novels did she buy then?
4. I mean, how many
Sorry,
novels?
magazines. I'm sorry, I misspoke speaking here. Can you fill in the
8.
rest of this table? Yeah. Okay, just making sure. Yes, it is B. Okay. All right. So we're going to switch to a new topic here. We haven't done much with statistics. Uh, you probably already know some of these. I'll just check with you. Do you know remember how to find the mean of a data set or the average?
Yeah.
Okay. How about the median?
The median is the it's the middle number, right?
It is the middle number. Now, let me give you a question here. I find it. It's actually a really deceptive question. So keep that in mind when you do this. What is the median of this data set?
Uh, 9.3. Oh wait, no, because you have to put in order. It would be
Yes, yes. Put in order. Yes, very good.
9.25.
Good, 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 good. Okay. Now let's say I give you a new data set, 1, 10, 13, and 20. There is no middle number. How do you find the median?
You find the average of the middle two number.
That's right. Okay, very good. All right. So now how about let's take a look at this data set again. Can you tell me the range of this data set? And if you need help, I'll define
Um,
this. I will give you that.
4.25.
Okay, how did you come up with that?
You subtract 5.5 from 9.75.
Yeah, so the max minus the min. Okay, we will do a few questions and then we'll jump back into some definitions if we need to. They're not like this. I mean, these are nice, questions. Um, so they're mostly tables and story problems, but like we've talked about, it's best to read the question, the call to action first, then go and figure out what you actually need.
Is it D?
All right, so what is the range for D?
Point
Point
four
four three.
three.
Yeah. The questions are any of the other ones close? You could do the calculations or you could just recognize that they're just not close. So yes, the answer is D. Right. Let's look. Hmm. What do you remember about box plots? And I'm going to put a box plot in front of you. It's okay to say you don't remember anything. I'm just wanting to know how much to kind of guide you through some of these examples.
Um, the middle line of the box is the median, and then the two end lines are the range.
This is the
And then
min, this is the max, and that you can get the range, yes, from that.
and
Yep.
then the mean is the box
We actually
itself.
we actually don't know the mean. This right here is called quartile 1 and quartile 3, but you actually you've identified enough here to be able to do some of the questions here. Okay. Actually, let's do this one first. Okay. All right. Go ahead and try this question, please.
D.
How did you come up with that?
9 minus 3 is 6.
You got it. Very good. Is this a difficult question?
No.
No. But you're going to get something like this on there. That's why we're covering it. So the easy ones you want to get correct and do them correct quickly, which is what you're doing. Sometimes you just need a refresher on this stuff. So that's all we're doing here is just reminding you of some things that you've seen in other classes. All right, go ahead and take a look at this question. Then we'll talk about standard deviation.
C.
Okay, so what is this thing saying down here at the end? If the two data sets are combined into one data set, what is the range of the combined data set? So um, how did you come up with C? I'm
Um,
not saying you're wrong. I'm just asking how you came up with it. It's a little bit odd. It's a good question, I think.
160 minus 10 is 150.
Yes. So basically you're saying, well, max of that one, min of that one. Very good. You got it. Okay. So there's they emphasize range and what's called standard deviation on the SAT. But what they don't emphasize is the calculation. Like you don't need to know how to calculate the standard deviation, although I think you should, but you don't need to in this test. Now, these are very much related. Typically, if it has a bigger range, that means it has a bigger standard deviation. And this is what both of these refer to is the spread of the data. Basically, which is more spread out. Okay. But let's just use some common sense numbers here. If I give you this data set and this data set, what is the range of both data sets?
2.
Two. Do these have the same spread of the data?
Yeah.
Yes. Like even though like one set of numbers is bigger than another, they have the same spread. So really you don't actually need to do standard deviation. You really want to almost look at just range instead of standard deviation for a lot of these problems. Meaning like the one with the bigger range is the bigger standard deviation. The one with the smaller range tends to have the smaller standard deviation. So you might be like, why is he even bringing this up? Or a problem like this one. All right, go ahead and take a look at that, please.
A.
Why is the standard deviation of data set B larger than that of A?
Because the range is bigger in
Yeah, yeah,
B.
that's basically enough for what you're trying to do. That's a shortcut here. Yes, it is A. Very good. Like what some students do is they actually put this in their calculator. This is actually a calculator question. L1, L2, they go and do the second calc, you know, one variable stats, and you don't need to do that. You don't need to do that for any of these questions. You really just have to interpret, which, I get it can be tough here. All right, so let's look at this table here, and then we'll look at the question. So tell me about these numbers and these numbers. Basically comparing them to each other. What can you say about A and B?
Um, B has like the number of values are bigger in B, but the range is the same in both of them.
Standard deviation. We'll say standard deviation is the same. So same spread. They have the same spread, but this one has a larger mean. You know, B is a larger mean, you could say, right? But they have
Hmm.
the same spread, even though, and that's kind of that was that whole example of using these numbers. Like these actually have different means. The mean of the first one is 2, the mean of the second one is 102, but their spread is exactly the same. Okay. So why am I showing you that? Well, this is, you know the pattern by now. This is a question. It's a question with a lot of words. Sometimes uh, they're just asking which statement is true on the right, which statement is true.
C.
Yeah, so variation is the same, not the same, but standard deviation and range and really variance, although I don't think they call it that. They all refer to this word variation. Okay, good. All right, so I think you're getting the pattern here. The other types of questions that you will be asked are based on graphs or tables. So this one says, which has the smallest standard deviation, which you could now replace with which has the smallest range.
D.
This one here?
Yeah.
Yeah. All right. Now, why does this have the smallest standard deviation? It's kind of true what we're doing. Now, if we were to draw like a curve to kind of give the shape of this, of each of these, this one's uniform. This one's also uniform. You know, this one you could see has the least amount of spread in it, which is the answer. Okay, so sometimes they give you a question where you don't get a graph, they give you a table instead. So what you have to do when you're given a table is convert the table to some sort of a graph. Like these values on the right represent the heights. And so maybe you can gather something from these because these ones actually have the same range. If you're not sure what I mean by that, I can graph these for you.
Would it just be C then?
No. So this is like the exception. That's why I said you gotta kind of gotta grab like this first one is like 3, 14, 2, 1, and 1. The second one is 6, 3, 2, 4, 6. All right. So the difference is that more of the data is clustered around the center, more of the data is spread out. So if we go back to the other drawings we did, like this one right here is more like data set D. This one right here on the bottom is more like B or C, or maybe even A. So like, it's not that that rule works all the time. You know, there's always an exception, but it's a pretty good one. So this one says that this one has less variation than this one. How does that change your answer if it does?
Um, it wouldn't.
Okay. Okay. So the correct answer here is that the B is larger in B. Argent B, because this is more spread out. This is more spread, even though the range is the same. So like this is less spread because more of the data is clustered around the center.
Mhm.
So it that range thing works like most of the time, unless they have the same range, then you really can't do that. All right, hopefully we haven't wrecked the whole lesson with one exception. All right, so let's do one more problem here to close out. You have an answer for me?
Uh, yeah, it's
So like, let me jump in here because we're running out of time. This is the min and this is the max. Now, I know you want to go to a calculator and grab them, and this actually leads really well into the next lesson, which is on estimation. These are about 1,000 in
it'd
parts.
be
So it's
D,
either one of those, right? B,
D.
D, yeah, it's D. Now, if you need to, you could grab a calculator. I think you could probably estimate that it is for sure D. And that's kind of the next thing we'll talk about is how to use estimation to save more time on the exams. All right, good job.